Good morning, students. Today we're going to continue our exploration of WPF, and in doing so we are going to delve deeper into dependency properties, dependency objects, and routed events, and we're going to see exactly what each one of those are, as well as how we can create our own. And to do that, we are going to start with this project, which is a continuation of one we built earlier. If you remember, we did a lobster pot game as part of our testing exercise, and we're going to build a graphical version of that now instead of a command line version. So we have kind of a starter project already set up for you. There's one other big difference that I want to draw your attention to, and that is this lobster pot DLL. So this is the compiled version of a library for implementing that lobster pot game. And if we were to look at the UML for this library, it really only contains one class, this game engine class, which consists of a revealed phrase property, a wrong guesses integer, which falls in the range of 0 to 7, previous guesses, which is a character array, and is1, is lost, and in progress boolean, which just report details about the game, the constructor, which is parameterless, and then this guess method, which will advance the game by making a new guess. So this is all stuff we've played with before. The only difference is this is now compiled and packaged into this DLL file that we'll want to use within the game. So we're going to have to take and add this as dependency to our project. And we'll do that by right-clicking on the dependencies, clicking Add a Project Reference, and then we're going to have to browse to this one because we have to browse to the location of that DLL file, which in this case is in my exercises folder and dependency property exercise, and we're working on the solution. We pick that lobster pot DLL. Notice that at this point it shows us the information has a checkbox like we've seen before. The difference is now it's actually referencing the DLL and the path to that DLL. So this is a little bit different than what you've done in the past where dependency projects were in the same solution. A DLL is a compiled library, so now we're just taking the compiled binary form and pulling it into our project. Now the other challenge is you notice this does not implement the iNotify property changed interface, so it's not really suitable for setting up for data binding directly. Also, some of the things like a character array are going to be not easily bound to. So we're going to handle a lot of the details here a bit differently than the game engine. So what we're going to have to do is we're going to have to create an intermediary class to sit between the game engine and our game XAML component to allow us to actually do that binding. So I'm going to create that at the top level, and I'm going to call that a, well, it will be a class, and I'm going to call it game view model because we're going to follow a pattern that Microsoft kind of put forth called the view model, MVVM. And what that really does is it separates, you have your model classes, which is the data classes describing your project, in this case our game class. You have your view classes, which are your controls, and in between those you have a view model, which does any kind of logic you have to do to convert the data that comes out of the model class for use by the views so that we can just use data binding pretty much exclusively on the view side. So the views don't have any logic in them anymore. We're trying to shift as much of that to this intermediate class or directly down into the model classes. And sometimes it makes sense just to use the model class directly. In cases like this, where we have to do some logic and we have to set things up to allow it to be bound, it really makes sense to add an intermediate class. And if we go back to that, let's go ahead and start by showing this revealed phrase, which is a string, in our UI. We want to show that as a detail that we can use. So we might, for example, declare here a public string phrase, which we would want to actually just get the one from our model class, and we'll need to construct that as well. So let's go ahead and declare a instance of that model class, which is in that lobster pot .game engine is the class name. And I'm going to call this model here, or maybe we'll call it game, equals new lobster pot game engine. So in our getter, we can just return that secret phrase. Property. And, or sorry, it's revealed phrase. And notice that that is now happy. Now, if you don't want to use the fully quantified name, we could add a using statement for lobster pot, just like we do with anything else, and that makes this unnecessary. We can just declare it as a game engine instance. Okay. So that gives us a revealed phrase, and we could, if we look at our game XAML, notice that the secret phrase is displayed with this component, the secret phrase component. So one of the things we probably want to do is we want to bind to the data context of the game a new in this case we called it the game model, so a new instance of this model class, and constructing that is going to create for us a new instance of the game engine and get it up and ready to run. And now we've bound that to our game control, so all the children of that game control, including this secret phrase component, are going to inherit that. So if we look in this secret phrase, there's not much going on just yet. We have a grid with no children. We might change this to be a text box, and we would like the text to be bound to that secret phrase property out of our game view model. So we could, for example, do a binding path equals reveal or phrase. We just called it phrase in that model. And we'll go ahead and close that. And once we do that, that looks like it's working fine. If we go ahead and run this, I used a two-way binding, a text box instead of a text block, because a text, the phrase only has a getter, it doesn't have a setter, so we can't do a two-way binding. And got some errors because I typed too fast. There we go. Try this again. And up here in the corner now we see that secret phrase, but it's really hard to distinguish how many letters are in this phrase, what this phrase actually looks like, and these are very small and not very good looking. So what we'd like to do is, instead of doing something like this, we'd like to replace that with some components that actually give us a good idea of how many letters we're dealing with, what those letters, what the shape of the phrase itself would actually be. And for doing that, it would be nice if we had a component representing each letter in this phrase. Let's go ahead and add a new component. So we'll use a custom user control, and let's call this secret letter. And we're going to kind of style this like maybe the letters in Wheel of Fortune. So I'm going to actually, instead of using design heights here, I'm going to give it an actual height and width of 60 pixels. And we don't normally do this actually setting hard-coded sizes, but in this case I think it makes a certain amount of sense. We don't need a grid here. We're going to have a text block again, but this text block is going to ideally show a single letter. So for now I'm just going to use an X as a placeholder, and it needs to be self-closing. And you can see that's a very tiny X. We'd like that to be bigger, maybe font size of 40. Yeah, let's keep it around 40. That seems to work pretty well. And let's go ahead and do a vertical alignment of center and a horizontal alignment of center. So we're just styling this a little bit so that it takes up the center of the space. Make this a little more readable. I'm going to add some new lines in there, and I'm going to shrink what we're looking at there. So there we have kind of our shape. And we'll set the border brush to black, and let's add a margin to that as well, and we'll set that to 4. Move this text box inside of that. So now we kind of have that nested Wheel of Fortune effect, where we have a little bit of space around that character. Okay, now we want this text to actually be bound to a property. Ideally, if we could come to the code behind and set up a property would be a character, we could bind it to that. But if we try to bind to this, it's not going to work because we're only allowed to bind to dependency properties. Because dependency properties give us some extra functionality that regular properties don't have. And to really understand why and how that works, we have to talk a little bit about what dependency properties actually are. So they're not actually defined this way, although we do expose them with a regular property. But the dependency properties are actually a part of dependency objects. Dependency object is a base object for pretty much everything in WPF, so all the controls are dependency objects. And a dependency object just has a collection, a key value store of dependency properties and their values. And this is, for example, how we can add grid.row and grid.column to objects that don't have a row or column property, because we're actually just adding them to this bag using the key grid.row and grid.column. And where that grid.row and grid.column come from is they're actually static members declared on the grid class. So the grid declares a public static column variable of the dependency property type. And we're going to go do that here as well. We're going to declare a dependency property for our letter. So we're going to start with a public static, and it has to be static because it's declared on the class itself, dependency property. And this dependency property acts like the key for that collection. That's what we store those values under. And we need to give it a name. By convention, it is the name that we want to use for the actual property plus the word property. And we're going to set that equal to, and now this is where things get interesting because we have to register with the dependency property object, the class object, to get a unique identifier to identify our particular dependency property. So we do that with dependency property dot register. This is a static method declared on the dependency property class. And it takes a couple arguments. The first is the name of the property, so in this case letter. And the second is the type of the property, because all values stored in this key value collection are actually objects, so we need to know what it's intended to be, so we can cast it back to that at some future point. And the property type here is a type of char, because we're actually storing characters for our letter. And then we want the type of the object this is registered to, and so in this case that would be our secret letter. And that is enough to get our dependency properties set up. And then down here we're going to change how this actually works so that it actually leverages that dependency property we just defined and adds and pulls out values from that collection of dependency properties. It's kind of like a dictionary. It's a key value store. So for example, we can invoke get value to pull something out of that store, and we have to supply the key, which in this case is the dependency property letter property. And what it will return to us is actually an object. So we have to cast this to be a char. Now we know it has to be a char because we've set up the code that way, but we have to explicitly do that cast operation. And the set, basically the same thing, except we're calling set value to set the value in that collection. And again, we have to give the key, which is the letter property, and then we can just pass in the value that our setter receives and have that be set as the value. So this is a dependency property representing the letter this control represents. The letter this control represents. And now that we've declared it as a dependency property, we can actually bind to it in our code behind. So if we come back to the secret letter code behind, or sorry, XAML, we can change this to a binding. And we are binding to the letter property. Okay, now this is not done yet, because when we say binding and give it a path, by default it thinks the source we're binding to is the data context, and that's not the case now. Now we want to bind to a property of this ancestor control itself, so the parent or several chains up the ancestor chain, which is this user control, because that property is declared here on our user control. And the way that we walk up that tree to grab that user control is we have to say a relative source. So we're changing the source that we're actually pointing at, and then we're going to declare a relative source. And we have to, these are the three properties we can set on that. We're going to set the mode equal to find ancestor. So we're saying we want to walk up the elements tree until we find a specific ancestor. And the type of that ancestor is going to be our secret letter, because that's where we defined this property on. And that should be good. I think we just need to do a build. And you can see there, now it's happy because it's built. It knows that secret letter has this property available. So this sets up showing that particular letter. Now if we come back to our secret phrase, we want to, instead of binding to this path phrase, we want to actually have a collection of these letter blocks. So I'm going to switch from, actually, I'm going to take this out entirely. Rather than using a user control as our base class, I'm going to change this to be a wrap panel. Because a wrap panel has the kind of behavior we actually want by default here. So I'm going to set that as a wrap panel. And if I change the type here, I also have to change it in the code behind. So we need to look at the secret phrase code behind, and notice that it inherits from user control. We're going to change that to a wrap panel so that our two halves of our partial class bind back together. Now that we have this as a wrap panel, we need to add a way of creating all of those letters that we want to reveal in this particular wrap panel. And there are a number of different ways we can do this, but since we're exploring dependency properties, let's go ahead and do it with another dependency property. So we're going to have a public static dependency property, and we're going to name this one phrase property equals dependency property dot register. And again, we have to give the name, and this is actually going to be the phrase. And we have to register the type of what we're storing, in this case a string, and the type of the control this dependency property belongs to, which in this case is the secret phrase. Okay, and that's where we stopped last time, but we're going to do a little bit something extra here as well. We're going to declare a property metadata, and actually what we're going to declare is a framework property metadata. So the property metadata describes more details about this property, and it's usually used to set what the default value of the property is. But if this property belongs to a framework element, so something that's actually rendered with WPF, we can instead use the framework property metadata, which also allows us to first off give the default value, but then it also allows us to do some description of how changing this property actually affects what we're doing with our project. And actually, I'm going to pull this out because it's going to get hard to see there. So I'm going to actually declare a framework property metadata equals, and paste that in there so that it's a little easier to read. And what we need as a second argument is metadata options, and these are flags kind of stored as an enumeration. So one of them is affects arrange, which says this affects the arrangement of all the elements in WPF. Affects measure is actually a little more valid here, because affects measure says that this might change how big this element needs to be. And then we're also going to do affects render, because this is going to change the way the control looks when this property is changed. And then we can also add a property change callback, which will be triggered when this actually changes. So we're going to declare a callback handle phrase change. And then we can go ahead and close that off. And here we're going to pass in as the third argument our metadata, which, what did I call that? Yeah, it's meta, capital D, data, and this needs to be static. Okay, so that sets up constructing our property, constructing. Let me go ahead and try to show a little bit more of this, because unfortunately it gets into very long declarations. We have metadata equals new framework property metadata. Default value is the string. We affect the measure and the render, and notice that we're using a bitwise OR here. We're declaring this handler, which we have to go declare, or we're invoking this handler. We need to declare that. And here we're declaring the phrase property. Its property name is phrase, its type of string, its type of secret phrase, and we're using that metadata. So also declare string named phrase. And the getter, we're just going to, again, use that get value, and we pass in the phrase property. And of course that's a string, so we have to cast it. And here I just use the lambda syntax. You can use that, or you can use the curly braces. Either syntax will work just fine. And here we would set value, and we'll go ahead and say that this is the phrase property and value. So either of those syntaxes work fine. Now we said we need to declare a static, and it has to be static to be able to be set in a static property void, because this is an event listener, and handle phrase change. And did I add a D on that? Oh. Let's go ahead and make it phrase change, just so it matches the verbiage that we've been using elsewhere. And the first parameter is the sender, and the second parameter is going to be a dependency property changed event args. So this is very similar to the property changed event args, but now it's for dependency properties. And in order to actually work with the individual instance of, because this is a static property, so this is throughout all the class, we're going to have to cast this sender into a secret phrase object. So we can do the if sender is secret phrase, and then inside of that body, we know that this will be our secret phrase. We have gotten our dependency property. So the first thing we're going to do is take this secret phrase, and remember our secret phrase is a wrap panel at this point. So we're just going to go ahead and tell its children to clear themselves. So we're going to drop out any old letters that we had. We're going to start brand new because we've got our phrases changed. What letters we need to display have changed. And then for each letter that we have, pair C in sp dot or secret phrase dot phrase, which is that property we just defined, we are going to add to our secret phrase children a new secret letter, and we'd like to pass in that character that we want to display. And because we're passing in a letter now, we have to go change the constructor for our secret letter. Now, if we do a constructor parameter, this actually means this cannot be declared in XAML anymore. So we're going to do a little alternate syntax. We're going to use the initializer syntax and just say that letter equals C. So then we don't have to change the constructor. We can go ahead and just set this initially to that whatever character came out of this secret phrase. And of course we'd want to go ahead and document all of this. But the result of this is now if we set that secret phrase, we should invoke this handle phrase changed, and that's going to go ahead and iterate through all the characters in the secret phrase, turn those into these objects. And if we go take another look at our game now, we could go ahead and bind this phrase property to our data context phrase. So path equals phrase. So this should now pull that phrase from our game view model, which is going to be the revealed phrase pulled from the game, and we should see that show up with a bunch of nice squares. Somewhere in here, oh, this needs to be, have an identifier, we'll go ahead and just call that E. Okay. And now you can see we have some space, we have our underscores, so we have a nice looking list tell us what our secret phrase kind of looks like. And I think in our secret letter, I added a border, but I didn't add a border thickness. So if we do that and run that again, we should actually have a box around each one of those now. There we go. So that kind of makes it clear phrase we're going for. We also have this interesting, so this is a space. We really don't want to have a box for that. So we can actually play some tricks with styles. I know we haven't worked tremendously with styles. But let's go ahead and add a style to this user control.resources. And we'll set our target type to text box. Or actually, yeah, let's set it to the text box, text block. And inside of this, let's set our background. Let's do a background color here, and let's set this to value equals light green. So I want this to actually be the color when we have guessed that letter. I'm going to add some conditionals in here so that we can change what this looks like based on how we're guessing. We'll add a style, triggers, and triggers are basically conditionals in XAML. They allow us to respond to events, change styles in response to those changes, or in this case, change it based on property values. So I'm going to use a trigger that is set with a property, and we're going to set that on letter. And we're going to say if the value is a space, then we want to trigger this setter, which we're going to change that property for the background to be white, which is the background of our game itself. So that should make that invisible if we take the border back off. And then we're going to do a second trigger, and we'll do this on the letter, and we'll say value equals, in this case we'll do the underscore. So these are letters we haven't guessed successfully yet. And let's go ahead and set the background there. Let's use bisque, which is kind of a creamy off-white. So that'll give us a little bit of distinction from the white. If we do this, we don't necessarily need our border anymore, and we might just move our margin directly into here then. So we'll set that at 4, rid of that second margin. So now this is all done through text block styling. And if I run this again and fix my errors, our target type is actually going to be local secret letter, because it's a secret letter we're changing that has this property. And that and actually now we're setting the background on the user control itself. And if that's the case, this margin actually we don't want there. We want to put that in our user control, so our user control has a little space between it and the other controls, which it also has a margin because it inherits from the framework. So if we run this again, there, now we have kind of a nice indication of where those letters are. Notice our space actually looks more like a space, and this is looking pretty good. I like the way that looks. Okay. So there's our secret letter and our secret phrase to get us to that point where we can display what those are. So if we go back to our kind of game display here, we're displaying the secret phrase, but now we also need to add some controls for choosing letters. So we're going to do this in this letter bank. We're going to actually create some buttons that we can use to click on to say that we're picking a particular letter. Let's go ahead and add, kind of like we did the secret letter, let's add a button component that's going to be our individual letter buttons. We're going to call this one letter button. And let it do a XAML base control. And go ahead and set the height and the width and the margin to match what we did for our letter, our secret letter, so that we're kind of consistent across these. And let's go ahead and we'll use a toggle button. Because a toggle button is a button you press down and it stays down or it comes back up. So let's call this pick toggle button, and let's go ahead and give 50 height, 50 margin 4, and that kind of gives us our button. And inside of that button, let's have a text box, text block, which is going to have the actual text of the letter that goes on this button. So we would want some kind of letter there, and then close off our toggle button. If type, and this needs to be self-closing. There we go. So that should give us a toggle button with an X on it. And it looks like I had an extra tag floating around there. Let's go ahead and scroll this up so we can see a little easier. We have our button. Let's go ahead and put that font size, maybe 50 or 40, do vertical align, center, horizontal alignment to center, those centered in our available space. Okay. I might make that just a hair smaller so it centers better. Yeah, there we go. That looks good. So there's our toggle button, and we're going to want to have that do a couple different things for us. First of all, when we click on it, we want it to go ahead and talk to our view model and basically trigger that event. We also want to display a specific letter. Let's start with that. This works pretty much exactly like we did on the last one. We're going to go to our letter button, code behind, we're going to declare a dependency property. And call this letter property as well. And then dependency property dot register. And notice that we are using the same property name and the same dependency property name that we used in our secret letter. And this is why you need to register these with the type of the control they belong to as well, because otherwise we could have potential name collisions between them. So our type of is going to be care, and our type of the control is going to be letter, button, and in this case, you could just declare a default value as well, but we're always going to be overriding this. And again, I declared this in the namespace. This should go inside the class. Okay, so now we have a dependency property. We need to create the regular property to go with it, which is type care. And again, our getter will just get value for that letter property, and our setter will invoke set value for that letter property, passing the value, and this needs to be cast to be a character, because again, we store these internally as objects, so we have to turn it back into a letter when we come back out. So now we can go back to our letter button XAML, and we can change this to a binding, and we can set the path equal to letter. And again, because this is actually bound to an ancestor, we need to use that relative source, and we're going to say relative source. The mode is find ancestor, because we're going to crawl up that tree looking for the ancestor, and the ancestor type is going to be a letter button. And of course we have to compile for this to recognize that letter button has that property that we just defined. With that much, we can go ahead and work on our letter bank, which is all the toggle buttons for all the letters in the alphabet. So we're going to go back to our Solution Explorer, and we're going to expand this letter bank. And kind of like we did in the secret phrase, I'm going to change this base class to be a wrap panel. We could also just put a wrap panel inside it and expose it with a name, but the wrap panel, just declaring it this way, works pretty well and pretty straightforward. Then we need the letter bank code behind. So in our code behind for that letter bank, the first thing we're going to want to do is go ahead and change this type from user control to wrap panel, so that both sides of our partial class actually match up with the same type, or inherited type. And then we're ready to go ahead and fill this with our buttons. And because this is a wrap panel, we could do children.add and add a new letter button. We want to do this for every letter button, or every letter that we want to represent. There's actually a pretty easy trick for that. We can use a for loop and declare a char c equals the first letter that we want to use, and then we can do a check that we are less than or equal to the last character we want to use, and then go ahead and iterate or increment that character value. So we're going to go character A, then character B, then character C, and we can do this because the character is actually a numeric value. So it is not any different than an integer in terms of how we're actually storing the value and how we can manipulate the value. It's just that normally when we display it, we're displaying it as the character that's represented by the numbers stored in the character. And then this letter button, we can go ahead and initialize to have the letter property set equal to that character. And when we do that, we should, every time we initialize a letter bank, we will run its constructor. We'll go ahead and do the initialize component step, and then we will populate our letter bank, which is a wrap panel, with these series of buttons. So if we go ahead and run this, we should see those toggle buttons show up for us. Oh man, left something in there that shouldn't be. Let's take that back out. And you can see across the bottom we now have, you can only see one row, but there's actually a second row underneath, which is the rest of the alphabet of these toggle buttons, and we can go ahead and toggle them, and we can untoggle them. They're just standard toggle buttons at this point. So we're going to actually edit their behavior a bit and make them actually submit a guess for the character that we want to see if it's in this phrase or not. And when we do that, we are essentially talking to this game engine, and we want to be able to invoke this guess property. So we need to go back and to our game view and expose this guess method. So if we jump back to our game view object, game view model object, we want to expose a public void guess char c, and we're just going to invoke on the game itself dot guess. We're going to pass that c down. Now in the actual game, that returns a true or false depending on if that was a correct guess or a wrong guess. And those change the number of wrong guesses if that's a wrong guess. So we actually need to potentially expose that as well. Public bool wrong guesses, and we can just expose the game.wrong guesses here. And the question is, if this is true, what are we going to do? And if it's false, what are we going to do? What logic actually belongs in this expression? Well, if the guess is wrong, then our guess is, oh, that's not a bool, that's an int. Then this wrong guesses is changing. And if it's true, then the revealed phrase is changing. So we need to actually make this report when those changes happen. And because we're using this for binding, we actually need to implement that iNotify property changed interface. So we're going to go ahead and add that in. And that, of course, means that we are going to add a public. Actually, I'm going to define this underneath our game engine. Public event property changed event handler property changed. And we'll just declare that as a regular old event, vanilla event. And then down in here, if that's true, what we really want to do is invoke that property changed event. If there's anything attached, and we'll invoke it with a this and a new property changed event args, and the property that is changing, I'll push this down to the next line just so it's easier to read. And it doesn't have to be in the curly braces, but we can certainly put it in the curly braces. Property that is changing is the, in this case, if this is true, then we have a correct guess, which means our revealed phrase is changing, which we are exposing phrase. And if it is false, then our wrong guesses are changing. So we say property changed, invoke this new property changed event args, and our string value here is going to be wrong guesses. And again, this needs to match the name of that property exactly. This syntax and this syntax are doing the same thing, so you can use either one, which is more comfortable to you. This is just kind of a shorthand for saying that you're doing a getter that returns a value. Here we're just saying this is the value that gets returned. Okay, so that hooks up our guess method, and now we need to figure out where we're going to trigger that. And if we're doing Windows Forms, we really wouldn't have much of a choice. It would have to go on this toggle button. We'd actually declare it there. But in this case, because this is a routed event, we have the opportunity of not just catching it in the toggle button, but it will actually bubble up, because this is a routed event that bubbles. So we could catch it in the user control, or we could catch it in the actual letter bank. So the letter bank contains all of those user events, or sorry, the toggle buttons. So we could catch it in this wrap panel, or we could catch it above that in our letter bank here, or in this dock panel, or in this user control, all the way up to the top level. I think it makes sense to actually put that logic in the game class. So let's go ahead and add it in here. So we will, inside of our game, create a handler void handle guess object sender, and then a routed event args. All right, and then in this event handler, we'd like to basically look at the routed event args, and we're going to pull two things out of that. The first of those is e.source. Now notice that the event has a source and an original source. The source is the object that actually started this routed event. Now normally we would use sender, but with routed events, the sender may not be exactly the object we're looking for. We really want to see which object fired off the source. And in this case, we would assume that that would have been the particular toggle button, or actually a little more accurately, the letter button that we are looking at. So we can check to see, is that actually a letter button? And we can throw this in an if statement, and we'll go ahead and cast it to be a new variable of type letter button button. And then we also need to get the game view model that is in our data context, so we can do a second if statement. So if the data context, and this is this data context effectively, if our current data context is a game view model, we'll go ahead and call this maybe GVM for game view model, and then inside of these two we want to invoke the GVM.guess, and we will invoke that with the button's letter. So this is the letter property of that button, which of course, because we made this as a letter button, should have that. And then finally at the bottom here, or after we do the guess, we will mark this as handled. So e.handled equals true. And we could do this handled here. We could also do it down here. What this means is that we have handled the event. It doesn't need to bubble up the events or the elements tree any farther. So this will stop the bubbling. And it makes a little more sense to handle it inside these if statements, because if our source was not the button, or the data context is not a game view model, maybe this is being triggered by something else and we need to handle it elsewhere, so let it bubble on up the tree. You also might dislike having nested if statements like this, and we could actually combine these with a Boolean and. It's okay to do this, even though these are the is casting pattern match operator. That will work, and it will just make that both of these variables inside the body actually match up with our expectation. Okay, so that is our event handler, and we need to go ahead and implement that event handler, and like we said, we'll do that on this letter bank. So we can say whatever event we're expecting to actually see, and this event is not defined here. We don't actually have an event listener in the letter bank that we can bind this to specifically. Rather, we're going to bind it to either a event out of the toggle button or its base class button. So for example, we could do the click event, which is button.click, and that is implemented on that toggle button. But in this case, I think we'll use the toggle button event itself, which is checked. So this is triggered whenever that button goes down, so when it's actually picked. And we'll go ahead and bind that to our handle guess. Okay, and oops, I got an extra in here, so let's get rid of that. So if we go ahead and run this now, and must have extra curly brace or no curly brace. So get that curly brace back in there so that this body is together. Run this again. And now if I click on a letter, I am making a guess. And there you can see I got a correct answer. And I'm also getting some wrong answers. So sometimes the letter will pop in, sometimes it won't. Now we're not actually dealing with the wrong guesses yet, but you can see we're getting the behavior we want here. Now I also can still uncheck these buttons, which is not really the behavior we want. There are a couple different ways we could deal with this. We could actually bind maybe a checked property to the model view class that we have, view model class. But actually the easiest way to handle it is to just jump back down to our letter button and add a event handler in the code behind as well for that is checked event. So void handle checked object sender routed event args e, and then inside of this body we'll just change the toggle button's property. See, so our toggle button has a name, picked toggle button, picked toggle button. I'm doing this in the wrong place. It needs to be in the code behind of the letter button, not the letter bank. So we'll jump right code behind, which is the letter button code behind. Button. Go. So I'll drop this after the constructor and get rid of our extra curly brace. There we go. So in here we should be able to get that pick toggle button, and we're going to set is disabled or is enabled to false. So basically anytime you check the button, we're going to immediately turn that button to be disabled so that it can't be clicked on any longer. And notice that we are catching the same routed event args, but we're not doing that e.handled. So even though we catch this here, it's still going to bubble up until it gets handled a little later on. So we'll go ahead and add this to our letter button XAML. So on this toggle button, we're going to add the checked event. We're going to set that to, checked event. If Visual Studio would behave for me, then we can bind that to handle checked. There we go. So we'll try this once more. And now you can see that as we pick things, they are now disabled, so I can't uncheck them anymore. So that's a really quick and easy fix. And also notice that we are seeing our correct results appearing up at the top. Okay. So now we're ready to think about, let's make handle our incorrect guesses. And we've already got this kind of set up to start with. We have this wrong guesses that we've added as a property, and we're invoking when we make a wrong guess, the property changed for that wrong guesses. So we really just need to bind another property to, this time, our lobster pot. So if we go to our lobster pot XAML, it's basically custom user control. We're defining a couple of bitmap images, and we're just layering them on top of one another. So in the background we have this pot image. On top of that we have this border who has a background, which image source is the bubbles, and then we do some animation with that, which is actually making those bubbles move up and down the way that we want. That's here, and this border.triggers. Basically, as soon as loaded event fires for the border, we start this animation, which is built out of a storyboard, and we're changing the background viewport property, and that's what makes those bubbles seem to be upwards. And then we have an image of the lobster, which you can't see, and the reason you can't see it is we've added this clip property and set a rectangle, which is a clipping rectangle, and that's saying how much of the lobster we should actually be showing, and we didn't give it any actual values, so right now this is showing nothing. So we're going to modify the code behind for the lobster pot to add a property, dependency property that we can bind the number of wrong guesses to, and let's call this public int reveal. And we want this to actually be a dependency property, so we're going to have to define the public static dependency property and reveal property equals, and then we have to do our dependency property registration. And we're going to register the name, which is reveal, and the type, which is int, and the type of class that we're binding this to, which is the lobster pot. And then our getter and setter is going to be getting and retrieving those values from the dependency property store. So grabbing the real property, and we have to cast that again because it's stored in that store as an object. We have to cast it back to being an int, And the setter, we're going to do the same thing, but we're going to invoke set value and the reveal property and our value. Okay, so that adds that property. Now, in order to actually make this change, that rectangle, we're actually going to have to do a little bit of a different approach. We're going to add a callback. This is going to be a public static function and our method, and it has to be static because we actually have to attach it to the property declaration. We'll call this handle reveal change. And a callback looks a lot like an event listener. It takes the object that is sending it, and it takes an event args. In this case, a property or dependency property changed event args. Okay, now because this is a static method, and we have to have return type void, because this is a static method, it actually belongs to the entire class, not to an individual object of the type lobster pot. But the change we want to make is to an actual lobster pot. So we have to take the sender object, which is the lobster pot instance, and cast it. So we will check that that sender is a lobster pot, and maybe we'll just call it pot. So what we want to do inside this handle reveal change listener is we want to change how much of the lobster is actually being revealed. If we jump back to the lobster pot, we're doing that with this clipping object, which we're setting to a rectangle. Now right now, that rectangle clipping is basically covering everything, so you don't see any lobster. But if we'd actually defined the rectangle that goes with it, the first two are the upper left corner and top, so this is the X, this is the Y of the upper left hand corner, and then we supply the width, in this case 300 pixels, and the height, in this case 750, and now you see the entire image appear. Now if we change where we're actually putting our top, for example if we push the top down by 50, we cut off the top of the image. If we push it down by 100, then, whoops, not 1,000, 100, we cut a bit more, and 350 is actually 7 times 5, and the amount of reveal we have has 7 increments to it, so it's going to start from 0 and go up to 6, or 7, so this is actually exactly how we can do that, is we want to change this in 50 unit increments. So we want to basically start with the entire lobster hidden, which is 350, and as we get more reveal, we want to actually show more of that. So in our event handler here, we can reference that clipping bounds object by its name. So in here we can say pot.clippingBounds. So we'll go ahead and set the rectangle value to be a new rectangle. A rectangle is a struct, so it's a value type, and we want that to be 0, 0, 300, 750 would be the entire lobster, but we want this to vary with that reveal property. So we'll put the reveal of the pot right here, and we have to do a little bit of arithmetic to make this work the way we want. So we subtract that reveal from 7, which is the total number of increments, and we multiply that by 50, and that's going to edge up or down the amount of or where that clipping rectangle is, so we'll actually see just parts of the lobster, and as that gets closer to 0, we'll see more and more of the lobster. So this will start at the tail and work its way back up, amount revealed. And we want to do that basically every time this reveal property changes. And we're going to have to add a framework metadata property to this, and we're going to do that. I'm going to go ahead and just construct it on its own line, so static framework property metadata, call it metadata, equals new framework property metadata. The first value is the default value. So in this case, how much we are revealing, which is going to be 0. And then we're going to give it our flags. This is going to change what this looks like, so we need to use the effects render to say that this has to be redrawn. And then we can supply a property change callback, which would be our reveal property change, or handled reveal property change. But there's a lot more that you can explore in terms of what metadata can do there. And we have to add this metadata as the last argument in our registration of that reveal property. And the result of doing this is that every time this reveal property changes, we're going to invoke the handle reveal change anything yet. So we've defined the full property, but it's not actually bound. So in our lobster pot, or actually in our game, let's bubble up to that level, and we want the control. Here our lobster pot, we now have a reveal property, and we can just bind that to our game view model's wrong guesses, which is going to be an integer between 0 and 7. So now if we run this, so if we make a wrong guess, notice that we get the first snippet of tail, and we will continue to get the lobster revealed. Now the next thing we need to do is we want to deal with the case when we complete the game. So either we win or lose. If we go to our game view model, and if we look at our UML diagram again, we do have this is won, this is lost, and then in progress Boolean values we can use to determine if the game is still going or if the game is over. Public bool 1, and just explore or expose that game dot 1. Actually, let's go ahead and call this is 1. Same thing for public bool is lost. Game dot is lost. And these are going to change after potentially each guess. So, for example, here, remember this if statement, we're checking to see if the game comes back with a true or false response. So if this is true, that means we had a correct guess, and there's a possibility that we may have won. So if game.isWon, property changed, question mark dot invoke, this new property changed event args is 1. And if the game is lost, this would happen after a wrong guess. So we'll do the is lost property and return that. Alright, so now after each guess we will double check that if we've lost or won the game, and in our game control code behind we have a method for resetting the game, which actually, if we think about the data context being a game view model, this is actually very easy to implement. We just do this exact same thing. So anytime we reset the game, we are going to invoke that. We have a method for display win, which shows a win dialog, and then once we exit out of the dialog, we reset the game. We have one for loss as well, which also resets the game. So we'll go ahead and set this up. And we just need to trigger actually these display win or this display loss when those events occur. So we might just go ahead and think about how we want to handle that. Let's add another event listener and handle property changed. And this would be a property changed event args that we'd be getting back. And we can just in here say if e.property name equals is 1, So if the property is the is1, and let's go ahead and get our data context as well, which we need to be a game view model. So data context is game model, game view model. So if check that the property was is1 and gvm.is1. So if got a change and that change happens to be that we just won the game, then we can go ahead and trigger that one, which I think is display win. And if instead the property name was is_lost and gvm.isLost is true, so that means is, then we're going to display loss. And finally, we have to attach this to our data contexts on property changed. So I'm going to change this code a little bit. I'm going to say var gvm equals, and I'll pull this out so that we can put it in a variable, because then we need to say gvm plus equals and attach that event listener to actually gvm.property changed. We're going to attach that event listener of handle property changed. And then we'll set the data context to that GVM. And when we reset, we need to do something similar. First of all, we need to get the data context back out. So if this data context is a game model GVM, we will remove the event listener from it, GVM dot property changed minus equals handle property changed, and then we will create a new game view model where GVM equals new game model and attach our property change to it. Property changed plus equals handle property changed, and then we'll set the data context to be GVM. And it's complaining because we're reusing a name that we declared up here, so let's make this old GVM and old GVM. So property changed. Now that reset should handle correctly. Let's go ahead and play our game one more time. So we have our lobster pot, we have our phrase we're trying to guess. So let's see. I have lost the game. You can see that it pops up this dialog informing me I have lost. When I click this OK button, it should reset the game. So now we have a new phrase and we're back working. So that is an exploration of the dependency properties and routed events and some of the ways that we can take advantage of them. You can see that this adds a lot of more complexity than we see in Windows Forms, but the trade-off is we have a lot more power and we can do a lot of very interesting things working with the framework elements, working with the dependency properties and dependency objects. It gives us a lot more freedom in how we lay out and design our controls. And we also can create a lot of very reusable controls that are very easy to work with and restyle them in some pretty dramatic ways. So that's where we'll stop for today. I hope you enjoyed it, and I hope you enjoy playing the game, and we'll talk to you later.